how to, in the case of Keras, we don't have to do anything like in the gradient descent. We have, we have implemented the gradient descent using our logic, right? We have used our program. We did not use any built-in sklearn functions to implement the gradient descent. We have written our custom gradient descent. For the gradient descent, we have written our custom function. When it comes to back propagation, you don't have to write you don't have to write any function to implement the back propagation. It is taken care automatically by the Keras. What is Keras? Keras is an API to your TensorFlow. So, TensorFlow was developed by Google. They have something called Tensor Processing Unit. How many of you know the GPU? GPU is a graphical processing unit. The graphical processing unit is much faster than your CPU, 100 times faster than your CPU. And the Tensor, Google, they developed an open source called TensorFlow. Right, TensorFlow, in order for their TensorFlow to run, right, they have developed something TPU, Tensor Processing Unit, that is much faster than GPU. That is what the Google says. Anyhow, the TensorFlow is the backend. With TensorFlow, we can implement the deep learning related models in a pretty simple and effective way, and the performance is also much faster with TensorFlow. And what I do is I just show you. But Keras is built on top of the TensorFlow. With Keras, you don't have to write many lines of code in order to implement your neural network algorithm or something like that. Okay, it makes the developer life simple. But with the latest version of TensorFlow, they made it everything simple. It's a way they made our the developer life much simple. But you need to install the TensorFlow and Keras. It's working fine in the laptop itself, hence we don't have to go to Google Colab and all. We can do it here. If you want to test it in Google Colab, you can use it. Especially when we work with deep learning algorithms. If you want to use GPU and all, we can go and use it there. We cannot afford to have GPU in our laptop, which is very costly. The same churn data set, I'm going to take it here. The reason why I'm using the same one is because you're already comfortable with this script. And also when you open this script, you should be able to see all the algorithms, how I implemented it. And the next session, what I will do is we have something called pipeline concept. Okay, and we will try to clean up, make our code more neat with the pipeline. You're not supposed to have the redundant code. Okay, so in this case, we have written, and I will show you how to create the pipeline, everything with the pipeline, how we can make our code more modular. Why it takes this much of time to load it? Okay, at last it was able to load it. Okay, let me just see. It's good, and the volume of the data is also less, hence it will be pretty faster. If I go down here, this is the one I'm talking about it. So TensorFlow, you need to install TensorFlow like this. Pip install TensorFlow, pip install Keras. And then once you install it, in my case, it got installed already. And next one is simply import, like this: import TensorFlow STF, in Keras models, import sequential, layers, import, these are the things. These are classes you need to import it from the Keras.models, layers, and optimizers. And you can see the model are equal to sequential. In model, in Keras is sequential, okay, which is a linear stack of layers. Right, so the first thing we need to get right is to ensure that the input layer has the right number of inputs. How many number of columns are there? This is your kind of your input layer. Sorry, this is your input layer. First, you create the network, and then in the first layer of the network is going to be your input or input layer. This is your hidden layer, and this is your output layer. Output layer, you can see only one neuron here, right? So here you can, in this case, I have mentioned 18, which means 18 columns I have it. Hence, create 18 input neurons. I'm talking about this one, the blue colored one, right? So in this case, we have only two columns are there. Here I have 18 columns are there in the churn data. Hence, I just import all those things because this one take time. The fully connected layers are defined using the dense class. What is the dense class? They'll ask you. What is sequential? Sequential is it's a model which is a linear stack of layers in the case of Keras. And in this case, we need to keep stacking the one layer after another layer. The first layer is going to be your input layer. The input layer, we have something called input dim. So what is shape one will give you the number of columns, right? And here create 18 neurons for, and then the input dimension is going to be 18. The activation function is sigmoid, and then the hidden layer sigmoid, and the last one is also sigmoid. In this case, it's a classification thing, right? Binary classification. Hence, we are in a sigmoid is okay. And the next one is the LR 0.1 stochastic gradient descent. Learning rate is equal to 0.1. I mentioned it here. So this one, the last one, this is where we obtain the overall output classification for our network. Okay, this one is the layer 3, which is our output layer, and the here in this case, yeah, the model.compile. Okay, this is the steps that you need to follow if you want to implement the basic neural network using Keras. First one is you need to define the layer. Okay, how many input layer, hidden layer, and output layers are required? In output layer, in each layer, how many number of neurons that you needed? What kind of activation function you needed in each layer? You need to define it, and then what is the um, loss function that you are going to, I mean, the optimization function, gradient descent, batch gradient descent, stochastic gradient descent. In this case, I mentioned about stochastic gradient descent. And the next step is, once you define your network, the next step is you need to use model.compile. Okay, and here the loss function I mentioned, binary cross entropy. Okay, binary cross entropy is the loss of a function used in the case of binary classification. In the case of multi-class classification, category underscore cross entropy is used. Okay, the loss function. And the optimizer equal to a stochastic gradient descent. You need to specify the optimizer. The next one is the metrics accuracy. Metrics is needed. And I just click on it here. Next one is fit. Oh, I did not execute this one. Okay, the next one is the fit. In the fit, we specify the data set, training data set, the input and output variables, and then epochs, how many number of iterations, and a batch equal to 4, right? So your batch. Any of this epochs and batch, I will explain you as part of the deep learning. Okay, don't worry. And the next one is the accuracy model dot evaluate. So as usual, right? So the typically what we do is we initialize the instantiate the model, and then next step is we use the fit method, and then we predict, right? The similarly here fit, but in this case in between It is little bit different here when it comes to Keras. First, you need to define the network design. This is kind of network design. You should be good with this one, especially when you work with the complex project. You should come up with the optimal number of values for the hidden layers neurons and output layer neurons. Okay, and then you need to specify the optimization function here. And next one is you need to define the loss function and using compile. After compile, you need to use the fit. Look, since we have mentioned 100 epochs is 100 iterations, it will happen. Okay, and then it automatically does the back propagation in this case. When you use Keras, every after one forward pass, the backward propagation will happen. The accuracy. Well, look here, it's still going on because of 100 epochs. It takes some time. If you have less memory, what you can try with Google Colab, okay, or else what you do is you can reduce the epochs 10 or something for learning purpose. Okay, here what is the final error we are getting? See earlier. Hmm, okay, now we are done. Okay, here we can see that how many number of epochs 100, right? 97, 98, 99, and 100. So 99, we can see that 0.87 accuracy. The error is slightly increasing it here, right? So, yeah, so 3929 and 0.3770, after which the error is increasing it. Okay, try with 150 epochs and see. And I think this is the cutoff here, right? So you need to use this because after this, the error is increasing. Error should not increase. Instead, accuracy should increase. But the error accuracy is increasing. But how come the loss is more than this one? Accuracy is 0.87. No, no, no. The accuracy is decreasing, right? 8712 is actually obviously less than this one. So here, this is the one. So it is converging at the 99th epoch. Epoch is kind of iteration. Batch, I will tell you later. The next one is accuracy. We are able to get a 0.86, 0.87, close to that point. This one is 0.386. Yeah, probably we can stop the, we can use the 99 as an epoch so that your accuracy will be getting this one. Okay, but here in this case, it is taking the average, it seems. Yeah, average here, average of all the things. Okay, and the next one is the compile here. Evaluate will give you the accuracy and the error loss. And the next one is the here also I've used. Okay, okay, in this case, what happened? This is an additional step. Instead of using stochastic gradient descent, we have something called Adam optimizer, like batch gradient descent, stochastic gradient. We have something called Adam optimizer. With Adam optimizer, we will see what is the accuracy we are going to get it. Compile, fit, and then evaluate. That's all. These are the steps that you need to remember it when it comes to Keras. The first step is you need to use sequential, right? So once you use the sequential class, you can define the network, right? So how many input layers are here? How many neurons should be there in the input layer? How many hidden layers are required? How many output layer? How many neurons are required? You can define it. First step. Second step is the compile. You need to compile. In the compile, you need to specify the loss function, the binary cross entropy for binary categorical variable, and then fit. Okay, and then the last step is evaluate. That's all. But here I just went one step ahead and to see with the Adam optimizer, can I see any improvement? The here we don't see much improvement, right? So here, let me just see here. Okay, here the accuracy is 0.87 training and the test is 0.86. 0.87 is good, right? Yeah, 0.87 is good. Here 0.8696, there is slight improvement here with Adam optimization. Fine, this is how you can implement the neural network using Keras, because nowadays the TensorFlow is very popular with TensorFlow, and we have something called um, for TensorFlow, the competitor for TensorFlow is PyTorch. Okay, and PyTorch, I have not used much. We did some POC, but I did not use it much. But if you know the TensorFlow and Keras, that is more than sufficient. Okay, any questions so far?